Hi, this video I'm going to tell about the threads, the concept of threads. First, we will see about what is meant by multi-threading. So, we have two different types of threading is available. One is a single-threaded process, and other one is multi-threaded process. Yeah, if it is a single-threaded process, means only one application can run concurrently. But in case of multi-threaded process, more than one application can be executed simultaneously. So that is a difference between single-threaded and multi-threaded. Most of the modern applications are nowadays multi-threaded. So the threads run within the application. So what is the advantage of multi-threading is when we use multiple tasks with the application can be implemented by separate threads. For example, we can update the display, we can fetch the data, we can do the spell checking, and we can answer the network request. So these and all can be done simultaneously by using the separate threads. And one of the main advantages of the thread is the process creation is somewhat costlier compared to the thread creation, because the process creation is heavyweight, but the thread creation is lightweight. So whatever resources the process is using, that resources only shared by multiple threads. So it is lightweight. And also the with the help of threads we can simplify the code and increase the efficiency. Kernels are generally multi-threaded, and we will see a architecture for multi-threading. This is a multi-threaded server architecture. So whenever the client is making a request to the server, what the server will do is server will in turn create a new thread to service the request. Here the server won't process the request. Instead of server will create a new thread to service the request, and it will resume listening for additional client request. So now the server is free, and whatever the request that came from a client, so it will create a thread for the new request, and that request will be serviced by the particular thread. It is not the server. So that is the main advantages of the multi-threaded architecture. And these are the benefits of the multi-threading. The first advantage is responsiveness. So what is responsiveness means, when we execute multi-threading, if any one process or any part of the process is blocked, means the other threads may be allowed to continue execution. So that is actually responsiveness. For example, if you are using single threaded process, suppose if you are pressing some key, if the key is not working, or the key is not responding, means it cannot do any operation. But in case of multi-threaded process, it may allow continued execution even though the part of the process is blocked. That is one advantage. And the second advantage is resource sharing. So what is resource sharing means, whatever the thread cannot use separate resources, whatever the resource that is available with the process, that resource is only shared by threads. So the threads share the resources of the process. It is easier than the shared memory or message passing. So whatever the resource that is available with the process, that resource only shared by multiple threads. So that is another advantage. And the third advantage is economy. So whenever we are creating a process, it is somewhat costlier. But when we create a thread, because thread is created by process, so it is somewhat cheaper compared to the compared to creating a process. So it is cheaper than process creation. And thread switching also lower produces lower overhead than the context switching of the process. And fourth advantage is scalability. So what is scalability means, the process can take advantages of the multi-processor architecture. We can increase number of threads within the process. That is another benefits. So these are the four major benefits of the multi-threading. One is a responsiveness, second one is a resource sharing, third one is economy, and fourth one is scalability. And this is a diagram for a single threaded process and a multi-threaded process. So when you look at the diagram here, so in single threaded process we got only single thread is available. So here we got only single thread. So but here we got multi-thread. In this diagram we are using three threads. So each thread will execute a different application. So, but in case of single threaded process, only one application can be executed at the same time. But in multi-threaded process, more than one application can be executed at the same time, that is simultaneously. And we have two different types of threads are available. One is a user level thread and other one is a kernel level thread. What is the difference is user level thread, the thread management is done by the user level thread library. That is, it is above the kernel level thread. There is uh, no use of the operating system here. So the thread management is done only by the user level. And there are three primary thread libraries are available for user level thread. One is POSIX pthreads, second one is a Windows thread, and the third one is a Java thread. And second type of thread is kernel level thread. So kernel level threads supported by kernel. And here thread management is done by the operating system. These are some examples for the kernel level thread: Windows, Solaris, Linux, True64 Unix, and Mac OS X. Now we are going to see about the different multi-threading models. So there are three multi-threading models available. One is a many-to-one model, second one is a one-to-one model, and third one is many-to-many model. We will see one by one what is the advantage of every model. First one is many-to-one model. So in case of many-to-one model, so many user level threads are mapped into a single kernel level thread. So here the many-to-one denotes for many user level thread, that is more than one user level thread and only one kernel level thread. So many user level threads are mapped into single kernel level thread. So when you look at here, only single kernel level thread is there. So here one thread blocking causes all to block. In case any one thread is blocking, means it will cause us all to block. So multiple threads may not run in parallel or multi-core system because only one kernel may be only one user level thread may be in the kernel at the same time. So example for the many-to-one model is Solaris screen threads and GNU portable threads. This is a many-to-one model, and again here many user level threads are mapped into single kernel level thread. Second model is one-to-one model. So what is one-to-one model is every user level thread, that is each user level thread is mapped into kernel level thread. Suppose if we are creating one user level thread, we need to create one kernel level thread also. That is creating a user level thread creates another kernel level thread. Here it produces more concurrency than many-to-one model. Here all the threads can be executed at the same time. So number of threads per process sometimes restricted due to overhead. So example, which are the operating system that uses one-to-one model is Windows, Linux, and Solaris 9. This is a one-to-one model. So one-to-one model, each user level thread maps into each kernel level thread. And the final third model is many-to-many model. What is many-to-many model is it allows many user level threads to be mapped into many kernel level thread. Unlike many-to-one model, so in many-to-one model, many user level thread are mapped into only one kernel level thread, but in many-to-many model, many user level threads are to be mapped into many kernel level thread. So it allows the operating system to create sufficient number of kernel threads. So the example is Solaris prior to version 9 and Windows with a thread fiber package. Thank you.